Okay, about limits and continuity. This is the part 11. Let's review what we have discussed before this period. We have discussed about the continuity. A function f of x is said to be continuous at x equal to a if the following condition be satisfied. The value of the function f of x at x equal to a, that is f of a, exists. Limit x tends to a f of x exists. Limit x tends to a f of x equal to f of a. If any one of the above conditions be filled, then f of x is said to be discontinuous at x equal to a. We'll be discussing about discontinuity later on. Also, f of x is continuous x equal to a if left hand limit, right hand limit equal to functional value. And about one-sided continuity, a function f of x or f is right continuous at a point or point a if fa exists and right hand limit equal to f of a. A function f of x is f is left continuous at a point b if fb exists and limit this is left hand limit equal to functional value. And about continuity of a function in an interval, a function f is continuous on the interval. Here I have shown in the figure as well. On the interval, in open interval, if it is continuous at every point of open interval, the function is continuous on closed interval. If it is continuous on open interval, to be continuous in closed interval, the condition should be satisfied, that is continuous on open interval of that closed interval and right continuous at a and left continuous at b. At the end point, right point a and left point b should be right continuous at a means left end point and left continuous at b, that is right side point end point, and continuous in open interval that we have discussed. And semi open if it is continuous on open interval and right continuous at a, the right close. And about left close if it is continuous on ab and left continuous at b, that we have already discussed more about this continuity of a function in an interval. And some properties of continuous function: if a function f of x is continuous in a closed interval this, then f of x has the greatest value in the interval. A function f of x which is continuous in a closed interval this cannot pass from one value to another in the interval without taking every indeterminate value at least once. If a function f of x is continuous in a closed interval this and f of a and f of b are opposite in sign, then there exists at least one value x equal to c in the interval such that f of c equal to 0. A function which is not continuous at a point x equal to a is said to be discontinuous. This is important property, but you will study in the next class or in next lesson. Now today I have to discuss about the algebraic properties of continuous function. Algebraic property, it is also the important uh, algebraic properties of continuous function. Algebraic properties of continuous function. Okay, firstly, let f of x and g of x be two real valued function continuous 8x equal to a and k be a real number. K be a real number. K be a real number. Then the following function functions are also continuous 8x equal to a. That is first case, k times f is continuous, like k times g also. And the second is f and g, sum of f and g. And third condition is fg. And the fourth condition is f by g, where g of a does not equal to 0. And others examples. Some other examples of some continuous function. Examples of some continuous function. First, a constant function. A constant function f of x equal to c is continuous on a real number r, real number, continuous on r. Identity function f of x equal to x is continuous on R. Number 3, it's important points. Every polynomial function is continuous on R. Number 4, sine and cosine functions are continuous on R continuous on R, but y equal to 10x is discontinuous at pi by 2, that means 90 degree, and its odd integral multiples. Odd integral multiples, maybe 270, 90, 270, in that way you can find. Similar number 5, the function e to the power x is continuous on R and ln x is continuous on R plus positive real number only. Check yourself why. The greatest integer function, greatest integer function, you may not know about greatest integer function, please explore, is continuous on R except at integrals point, integral points. So this is also the general information, but it helps you to write some properties, or if you have to write some conditions, then it may be helpful हैन. सिम्पली अहिले तिमी कन्टिन्युटी दुईटाको प्रोडक्ट के टाइम्स रियल नम्बर टाइम्स द फंक्शन सम प्रोडक्ट र कोसन्ट त्यो पनि कन्टिन्युअस हुन्छ इन स्पेसिफिक पोइन्ट भन्ने एउटा बुझ्नु पर्यो. दोस्रो कन्स्टेन्ट फंक्शन कन्टिन्युअस हुन्छ, त्यो प्रब्लमै छैन. आइडेन्टिटी फंक्शन नि कन्टिन्युअस हुन्छ. पोलिनोमियल फंक्शन पनि रियल नम्बरमा कन्टिन्युअसै हुन्छ. साइन र कोसाइन फंक्शन कन्टिन्युअस अन आर हुन्छ, बट यसको डोमेनमा कन्टिन्युअस हुन्छ भन्दा अझ व्यवहारिक होला. 10 को चाहिँ हुँदैन यो 90 मा, किनभने 90 को भ्यालु इन्फिनिटी हुन्छ यु नो. र त्यस्तै अड इन्टिग्रल्स त्यसको अड मल्टिपलहरुमा 3π/4 के भन्छ त्यो यो पाइ 270 एन्ड सो अन. एन्ड e टु द पावर x इज कन्टिन्युअस इन r हुन्छ, तर ln x इज कन्टिन्युअस इन पोजिटिभ r हुन्छ. यो कुरा किन भन्ने कुरा खोज्ने तिमीले. एन्ड द ग्रेटेस्ट इन्टिजर फंक्शन भने के हो खोज्ने, यु हैव टु आइडेन्टिफाई दिस. एन्ड यो चाहिँ एक्सेप्ट एन्ड इन्टिग्रल पोइन्ट्स, यो पोइन्ट्सहरुमा यो जम्प हुन्छ, यसको रिजन चाहिँ त्यो हो. यो ग्रेटेस्ट इन्टिजर, व्हाट इज ग्रेटेस्ट इन्टिजर फंक्शन, र ln x इज कन्टिन्युअस r प्लस ओन्ली y. दिस इज योर टास्क, you need to identify. And what are the odd integral multiples? 3 points you should find yourself. That is as a class homework, dear students. So be sure that these 6 properties are very important in continuous function. Okay, now we have to discuss about types of discontinuity, dear students. Types of discontinuity. Types of discontinuities. Types of discontinuity, or discontinuous function may be the following types. May be the following types. First of all, if limit x tends to a, f of x does not equal to f of a, then the function f of x is said to have a removable discontinuity. Removable discontinuity at x equal to a. This type of discontinuity discontinuity can be removed by redefining the function. We will discuss the example later on about a removable discontinuity. Again, I want to highlight about this. Limit exists, left hand limit equal to right hand limit, but the functional value is not equal with the limiting value. Such condition of the function or this is a removable discontinuity. We can remove the discontinuity of the function. In this situation, we have to redefine the function. It means what's the limiting value is, we should define the function in such a way that at that particular point x equal to a, we will get the functional value equal to limiting value, or what is the limiting value in a same way, or in a same the functional value. We have to redefine the function as to obtain the limiting value, or we should find both values should be same हैन. त्यो रिडिफाइन गरेर तिमी लिमिटिङ भ्यालु जति नै फंक्शनल भ्यालु पाउने गरी रिडिफाइन गर्नुपर्छ फंक्शन. Okay, now second discontinuity. If limit x tends to a, f of x does not exist, that means a limit x tends to a minus f of a does not equal to limit x tends to a plus f of x, then f of x is said to be an ordinary discontinuity or a jump. Left hand limit and right hand limits are not the same here. In that case also, limit does not exist. The function will not be continuous. In this case, it is ordinary discontinuity, or maybe it may be jump. Maybe the value may be differ. And the third, dear students, if limit x tends to a, f of x tends to positive infinity or negative infinity. In this case, the function f of x is said to have infinite discontinuity. Infinite discontinuity at x equal to a. And let me add one more discontinuity. The discontinuity is said to be oscillatory when the limits of f of x oscillate between two finite quantities. For example, f of x equal to sine 1 by x, or f of x equal to cos 1 by x at x equal to 0. You know, it will oscillate that particular point or the interval or between two finite real quantities. For example, one function I will write here. uh, f of x equal x square minus 4 by x minus 2 at x equal to 2. Can you tell this is continuous function or discontinuous function? With reason. Sisir Bara.
Discontinuous.
Why? Why it is discontinuous function? F of x equal to x square minus 4 by x minus 2, yet x does not equal to 2, and 3 at x equal to 2. Shishir Baral. Second number question.
Discontinuous.
Why?
Because functional value is not equal to limiting value.
What is the limiting value?
4,
What is the functional value?
3.
And this is discontinuous. Can we make what type of discontinuity is this? Yes. What type of discontinuity is this?
I think it is a removable
That's
discontinuity.
good. That's great. Then how can we remove it?
We can remove it by defining at x equals to 2 function is equal to 4.
Oh, we cannot. That's good, but we cannot redefine this function. Just only we can redefine this function. Okay. Limiting function we cannot redefine. Only for functional value we can redefine. So what is limiting value?
4.
Yes, for the meaning of x does not equal to 2 means.
When x approaches to 2.
Yes, this is for right hand limit and left hand limit. That's good. X does not equal to 2 means this function is for right hand limit and left hand limit. X equal to 2 means this is for functional value. So we can redefine this function. So if we redefine the function as f of x equal to 2 at x equal to 2, or in other ways to obtain the functional value 2, then the function will be continuous. That's great. Now say third question, Sisir. The function f of x is minus x square plus 3 for x less or equal than 4, and simply x square for x greater than 4 at x equal to 4. Can you tell me this is continuous or discontinuous? This is continuous or discontinuous, and why and what can we do? Shishir, are you there?
Yes, sir.
Okay, can you tell the answer of this question number 3? Shishir, yeah?
I think it is discontinuous.
Okay, then why and yes, why? What is left hand limit? Can you tell me the left hand limit? I think you have done this problem in your copy as well. What is left hand limit?
Minus 13.
And what is right hand limit?
16.
16. And what is functional value?
Minus 13.
Yes. Right hand limit and left hand limit. This function is taken for right hand limit, left hand limit and functional value as x less or equal to 4. This is taken for right hand limit. We obtain left hand limit equal minus 13, functional value equal to minus 13, but right hand limit equal to 16. Right hand limit and left hand limit are not equal. That's why the function does not exist. The limit does not exist. They are not equal. So shall we redefine this, or is this removable discontinuity or not? Shishir.
I don't think it is removable.
Yes, it is not removable because only we can redefine this function because the limit does not exist, so we cannot redefine this. That's a good discussion. Now the next functions here I am asking only with you. today. F of x equal to 1 by x minus 2 8 x equal to 2. It is continuous or discontinuous?
Discontinuous.
Yes. Why it is discontinuous? Why it is discontinuous? Ayush on.
Because
Yeah.
limit is also not defined and functional value is also not defined.
Yes. Both left hand limit and right hand limit doesn't exist. Yeah. Okay. Now last question of function is f of x is x square plus 1 8x equal to 3. Is it continuous?
Yes, sir.
Okay, I think all the values are limit exist and limiting value equal to functional value. The fifth function is continuous. One question we can discuss, dear students. I will not discuss ordinary question. One question. Yeah. Test the continuity or discontinuity of the following function by calculating left hand limits, the right hand limits, and the value of the function as specific point or 8 points is specified. That is the instruction given in the exercise, dear students. Let me ask one question, simple question you can discuss. Before that, I should list the question. First one is f of x square 8x equal to 4. Number 2, f of x equal to 2 minus 3x square 8x equal to 0. Number 3, f of x equal to 3x square minus 2x plus 4 8x equal to 1. Phone number, f of x equal to 1 by 2x 8x equal to 0. 5 number, f of x equal to 1 by x minus 2 8x does not equal to 2. 6 number, f of x equal to 1 by 3x 8x does not equal to 0. 7 number, f of x equal to 1 by 1 minus x 8x equal to 1. 8 number, f of x equal to 1 over x minus 3 8 x equal to 3. 9 number, f of x equal x square minus 9 over x minus 3 8x equal to 3. 10 number, f of x equal to x square minus 16 by x minus 4 8 x equal to 4. And 11 number, f of x equal to more x minus 2 over x minus 2 8 x equal to 2.